Senior Engineering Manager from Google, Tim Bray.
Hello. So today we are going to have a technical presentation. I hope you are technical. We're having a technical presentation about high performance in Android apps. Now, when I talk about high performance, I really mean two different things. The first is, how do you make your app run fast? Because everybody agrees that a fast application provides a better user experience. So we will talk about how to make things fast. But then there's the other side of the problem, which is some things are not fast. If you want to fetch a web page, or if you want to update a database, these things are not fast, and so sometimes you have to do things that are slow. So how do we do these things in a way that does not make the users unhappy? Because our goal is always the same. Our goal is to have happy users. So let's talk about the user experience. So in the Chrome team at Google, they invented this word jank, and it has become very popular. All over Google, you hear people talking about jank, and they say janky if something has jank. And it's whenever the user can perceive a delay. So if I touch something on the screen and move it, and it stops, it doesn't go smoothly, that means it's janky. And the user really doesn't like it when it gets janky. The user doesn't understand why he's unhappy, but he's unhappy. Now, an Android device, like a Nexus 1, typically runs at 1 billion cycles per second or more. So there is no excuse for jankiness. The key principle that we have to remember is that Android applications can run on many Java threads, but one of the threads is special. One of the threads is called the user interface thread, the UI thread, and it has control of the screen. And the key principle that I'm going to talk about today is that you should never do the application work on the UI thread, because that's how you get jankiness. Now, specifically, if you are bad and you put heavy application logic on the UI thread, this happens. That's the worst thing in the world. Users hate this. You should hate this. In the Android Developer Relations Group, we get many, many, many applications to review, to evaluate, and maybe to feature in Android Market. And if we see one of these, the application is gone. This is completely intolerable. Now, what makes this happen? So you get an application not responding is if I have a tap on the screen and I have a tap handler in my program and it goes 5 seconds with no response, application not responding. Or if I have an intent receiver and an intent gets fired and it's passed to me and I take more than 10 seconds to handle, application not responding. So you must never, never, never let this happen. But actually, the problem is much more difficult than this, because users are sensitive to delays that are much, much shorter than 5 seconds. I will give you some detailed numbers. So suppose you are playing video, fast video, 60 frames per second. So each frame is 16 milliseconds. And we have done many studies, and they show that users can perceive delays as soon as they reach 1/10 or 1/5 of a second. So if you ever stop the user interface thread for 1/5 of a second, you will have jank. You will be janky. So you mustn't do that. So let's look at some of the details from a Nexus 1 Android device. So if you look at the first 2 points, doing inter-process communication is actually very fast. Even on the UI thread, you have time to send many messages back and forth between processes. So you should not be afraid of that. It's perfectly okay to do a lot of inter-process communication. On the other hand, as soon as you touch the storage, the flash storage, the situation becomes much worse. So just to read a byte, to read 1 byte from the storage, it can take as long as 25 milliseconds. And if you are writing into the storage, the situation becomes very complex and very nasty. Just to write, make a small write into the storage can take 1/5 of a second right there. Okay? And of course, the storage is bad and the network is much worse. Just to send a ping to a server and get the response back can take as long as 800 milliseconds, almost a second, when you're operating over 3G. And if you look at the architecture of 3G networks, you discover that they are very complex, and it depends on a lot of variables. How strong the signal is, how many hops in the network, lots of things. So you can't even predict how long that's going to be. Now, what is the most common operation? What is the most common network operation that Android apps do? HTTP. We go and get something from the web with HTTP GET. So to set up the TCP and get something, it will almost always take at least 1 second. Depending on what it is, it can easily take many seconds. Okay? So all of these are things that can take a lot of time and ruin your user experience and make your user unhappy. Here are some details about how long it takes to write something to the persistent flash storage on an Android device. And the transaction here is we create a file, we put a few bytes in it, and we close the file. It turns out that this is behavior very similar to SQLite when it does its journaling operations. Now, the behavior of Flash is quite different from the behavior of magnetic disks that we are all used to. And if you look at the graph, you can see that the performance depends on what kind of a device you have. It also depends on how full the flash is. And here's something else that the graph does not show. It also depends on how old the phone is. So it's very complex and it's very hard to predict. And the rule is that you must never, never, never do storage or retrieval operations on the I/O thread, on the user interface thread, on the UI thread. Okay? Now, as we all know, the Android framework includes SQLite for database operations. And people think that SQLite is a small, simple database. And it is small and simple, but only by comparison to other databases. In fact, it's a large and complex piece of software. And if you do something like explain query plan on a simple SQLite transaction, you will be amazed at what the database is doing. And of course, with relational databases, you always have the same trade-off. If you put an index on the table, then the retrieval will be much faster, and the update will, of course, be much slower. So you have to be really careful in how you use the SQLite database. And of course, you must never do it on the UI thread. Now, one thing we see a lot that we think is a very bad idea is many applications need to do logging. They have to save the progress of what they do. And sometimes we see them doing logging into an SQLite database. And that's a really bad idea. It's much, much better just to open a text file and do print line into your text file. It's still not fast, but it's much more predictable than using SQLite. So please take our advice on this. So the lessons that we're teaching are obvious, that I/O is slow. You know, on a modern phone, on a Nexus 1 or a modern phone, computation is actually quite fast, but I/O is very, very slow. And it is absolutely true that a slow application will never get a good review. It will get lots of uninstalls. If you want to have a lot of people use your app, if you want to make some money from your app, you have to worry about performance all the time. So, what I've said this 10 times. I can say it 10 more times. You have to get the slow stuff off the UI thread. It's the only thing. Now, it's easy for me to say that, but in fact, it's a little bit complex to do thread programming in Java. Anybody who's done it knows that it's tricky and there are lots of problems you can get into. So we provide some tools to make it easier. One very nice tool is a tool called Async Task, which is in the Android toolkit. And suppose you want to do something slow, like save a bunch of data. So what you want to do is you want to do it in the background on a background thread, but you want to display a progress toolbar. You want a progress bar to the user so they can see what's happening. Now, the rule is that if you want to update the progress bar, you have to do that on the UI thread. But if you want to save to the database, you have to do that on a background thread. And organizing this can be quite difficult. You have to handle runnables, and you have to send events to threads. And Async Task makes that much easier. So, do we have a laser pointer? No? Oh, well, never mind. Okay, so here's an example of using Async Task. I hope you can see the code. Probably the people at the back can't see the code. I'm sorry. So an Async Task is an abstract class, so you have to extend it. And so you make your Async Task and you call a method called execute, which you see on the bottom line there. And what this does is it eventually calls a method called doInBackground, and that happens on a background thread that it creates. And it also provides a method that you can call called publishProgress. And when you call the publishProgress method, which you see about a third of the way down there, it will arrange to call the onProgressUpdate method on the UI thread. So by calling this method in the background thread, you can have your routine called in the UI thread to update a progress bar or something like that. Also, it provides a couple of other very useful methods called on Pre Execute and Onpostexecute. So you see that in this example, what he's doing is he's downloading a bunch of files. So downloading a file is obviously a slow and expensive operation. So what he does is each time he downloads one file, and then he calls publishProgress. So that will go to the UI thread, and he will probably move the progress bar over, or something like that. Okay? So this makes a lot of the work of doing things in a background thread go away. I strongly recommend using this. It makes everything easier. Now, here's another usage of Async Task. And in this case, what's this one? Oh, yes. This is from the browser. And every time you visit a page on the browser, it wants to update the browser history. But you don't want to wait. You don't care about updating the browser history. So it wants to update the browser history in the background, and it doesn't want to tell you. There's no user interaction at all. So we call this fire and forget mode. So he goes and makes a new async task and just calls .execute on it, and it just goes away in the background and does it. So this takes care of all the work of setting up the background thread, running it, handling its exit, everything. I highly recommend it. So here are some of the rules for async task. Be careful. You can't call it recursively. If you're in one async task, you can't call another async task. It really has to be called from the UI thread. It has to be started from the UI thread. Now, there's one thing you have to watch out for that can go wrong. If you have an activity and you call an async task, and then the user presses the back button or presses the home button, and your activity is placed in background, it's possible that your activity could be cleaned up by the system because of a lack of memory, for example, while the async task is still running. and this could be a real problem. So for this kind of situation, we have another convenience function called intent service. And for something that is running in the background that you don't want the system to kill, you should always use an Android service. But if you've ever done this, you know that setting up an Android service is actually quite a lot of work. There's a bunch of boilerplate code and bookkeeping and stuff that you have to set up. And if you have a simple service that you want to run in the background, intent service takes care of that. And the nice thing is that if you start a service and then your activity is cleaned up by the service will continue running, and the system will try very hard not to kill the service. So that example I showed you of the updating the browser history, it should probably be done with intent service and not async task, because it would be much safer. So here's an example of how this works. So this one is from the calendar program, and I know everybody who has an Android phone knows that you get a bunch of updates in your notice bar, and you pull it down and it says, oh, you have this meeting, you have that meeting, you have that meeting, and you press one button that dismisses all those alarms. Okay? So the system has to go run the calendar has to go run a bunch of code to clean up the pending alarms and clean up the state of the calendar. And this is actually quite a lot of work, and it requires updating the storage. So it's pretty slow. So what he does is he makes an intent for that and just goes and says start the service, and so that will run in the background and it will not be dismissed. So first of all, we are asking you, please, don't do anything slow on the UI thread. And to help you out, we are providing these nicely packaged convenience routines so that you can do your work in the background. Now, writing this kind of code is hard, but providing a good user interface is actually much harder. I think we all agree. The hardest part of writing an Android app is getting a good user experience, a good user interface. And sometimes the user will have to wait. If I am, downloading a big file, or if I am saving something, the user will have to wait. So it is your duty to be polite to the user, to tell them what's going on. It's never acceptable just to freeze. So you have to think a lot about what you're going to do to make the user happy. So the first thing you should do, if you are doing something that takes a long time and you don't want the user to be pressing buttons, so you should disable all your buttons and controls immediately. And then you have to decide what visual tool should you use to show the user that you are busy. So Android has a bunch of different tools like this. So for very short things, you can just show the little spinner in the notice bar. That's a good method. And this is a suggestion from one of our engineers saying, well, for the first 1/5 of a second, show the spinner, and if it's going to take longer than 1/5 of a second, show some sort of a progress dialog, a progress bar or a text explanation or something of what's happening. And then, when you find out that it's finished, you can cancel that. But it's really, really important to be polite to your user and show them what's going on. Now, I'm going to show you an example of a little program that I wrote that does that. So I have a little app in the Android market called Lifesaver. Now, if you have an Android phone and you get a new Android phone, it will transfer all your contacts and calendars and mail automatically. One thing it does not transfer is the history of your phone calls and your text messages. And for me, this is very important. It's part of my history. It's my life. So I made a little app called Lifesaver that will take all your text messages and phone call history and copies it onto the SD card in your old phone. Then you take the SD card out, put it in your new phone, and you run the program again, and it will bring all your old phone calls back and all your old text messages back. So let me show you that. Can we have the phone, please? Okay, so here's the program, Lifesaver. And it's very simple. So I'm going to say, save your life. And it says, oh, there's already a life here. Is that okay? And you say yes. And as soon as I do that, it starts showing you things. So you can see what it's doing, right? So, and then it's finishing. Okay, you can go back now. So there's no way to make that fast. In that case, you saw it. Saved several hundred phone calls and text messages. It just can't be done quickly. So you have to be polite to the user. You have to give them something to look at. Okay, can we go back to the slides, please? Okay. Let's talk about something else. We've been spending the time so far talking about being polite to the user. Let's talk about the other subject is, how do you make programs run fast? And I have some bad news for you. If you are going to write an Android app, and it is a reasonably complex app, you are not smart enough to predict what will make it slow. Where are the bottlenecks? Where are the performance problems? Nobody is smart enough to predict what will make a computer program run slowly. Trying to guess and optimize your program in advance is a very stupid thing to do. I've seen a lot of young programmers, in particular young male programmers, who can't resist it. They have some simple thing they want to look up, and they say, oh, I will put that in a dynamically balanced hash table so it will be fast. And they spend 3 weeks coding the hash table. And how do they know? Maybe it'll be fast enough. So premature optimization is always a bad idea. So here's the sort of approach that a mature software professional would recommend. So when you design your code, your Android app, you do it in the simplest way that can possibly work, okay? Now, that doesn't mean it's okay to do I/O on the UI thread. That couldn't possibly work. So you find the simplest way to do things that could possibly work, and then test it. Maybe it'll be fast enough. Then you go have a beer. You're happy, celebrate. You're finished. But probably the first time you run your Android app, you'll discover it's not fast enough. So if it's not fast enough, you should not guess why. You have to measure why that is. So you measure, and if you are lucky, you will find that there is one small part of your program that is using almost all of the time. And in that case, you can fix it, and then you go have the beer because your program is now fast enough. But usually, you have to repeat this loop a few times. You measure your program, you find what is slow, you make it fast. So Android actually provides some pretty nice tools for to do this on Android. So in English, when we talk about measuring the performance of a program, we call it profiling, to make a program profile. So there is really a very good tool called Traceview, and I'll show you Traceview and show you how it works. But it's a little bit of extra work. In many cases, it might be easier to just put in some logging calls. So just say log.d and then the timestamp, and I started saving the file. I ended saving the file. I started making the web contact. I finished making the web contact. So sometimes just a few little messages in the file will be sufficient to find out where your program is spending its time. Now, there's a case of extreme profiling, and this is what we do at Google. And now, if you have a program that you are very, very, very concerned about the performance, for example, a game. So what we do at Google is we take the Android apps, and we get thousands of Googlers to use them, the people who work at Google, and we instrument the program so that it writes profile data up to the server. And so then we get profile data from thousands of people, and we can aggregate it all together and we find out with a great deal of accuracy what is the behavior of the program. Now, clearly, you can't do that with your customers. That would be a major privacy issue. You can't do that. But, for example, if you are a game company and you're developing a game with 10 developers, have 10, 20 people play the game for 6 hours and get the profiling information from all of them. You'll get a huge amount of information that way. So I'm going to now show you how Traceview works. So it's really pretty simple. You can do it from ADB. You can type an ADB command to tell a program to start tracing and stop tracing. Sometimes that is useful. I actually find it much easier to do this with actual calls in the Java code. So let's do that. Let us do tracing on Lifesaver, that program I just showed you, because it took a while for that progress bar to go across. And suppose I say, I want to make it faster. So if I want to make it faster, I have to find out why is it slow. So let us go and do that. So I'm going to stop the talk here, and we should see, oops, okay. I don't need that. Okay, so here is that code, actually. Here's Eclipse. So this is the call that saves those things to the SD card. So it's actually pretty simple. We open up a file, a print file on the SD card, and we print the number of calls that are going to be. And where this thing calls, this is a my mind's gone blank. The SQL thing, a data source, content provider. The calls is a content provider that the system provides to read the log of your phone calls. So what you do is you say, well, I have one more phone call. I print, I take it and I turn it into JSON, a textual format, and I print that out into the file. And I increment the save calls, and I go and update the progress bar. I didn't actually use async task here. I should have. So I'm doing all the threads myself. Okay. So then I read all the calls. Then I close that file. I close the file and the cursor, and then I update the message saying how many I saved. Then I do the same thing. I get the messages. I print how many. I go and this is another content provider on the messages. And I only take the ones that have addresses, and I convert them each one to JSON, and then I print it out, and that's all. Okay? So we saw that was running a little bit slow. Okay? And if I were going to guess why is that running slow, I can think of 3 places the delay might come from. Okay? It could come from reading the phone call log out of the content provider. Okay? It could come from the delay of saving the data onto the SD card. Or it could come from the computation here. Just turning it into JSON and things like that. So let's think for a minute. You're all computer programmers. Think in your mind, where do you think the delay is? So make a theory in your mind, and then we'll go and find out the truth, and we'll see if you are surprised. So what I'm going to do is I'm going to go here. Okay. And I'm going to say Android.os.debug.start method tracing. And I give it an argument, which is Lifesaver display. Okay, so it'll put it in a file of that name. And I'll go down here to the end of the method. Oops. And I'll say, oops. Android.debug.stop. What am I doing wrong here? It's Android. What am I doing wrong here? Debug.stop. Stop. I hate Eclipse sometimes. Okay, what's wrong here? Oh, is that outside the class? Oh, right, you are. Pardon me. No. Oh, yes, you're right. It should be here. Pardon me. Thank you. There we go. Thank you. Okay, so then what I'll do is I'll just actually run that. Now, okay, can we switch to the projector here, please? Projector? Okay, so I'll run that. Oops. So that'll go and install a new version of that. Yeah, there it is. Now I'll run it again. Now you'll notice it's actually a lot slower, okay, because I put the tracing code in there, and that makes it run slower. Okay? Thank you. Can I have the projector back, please? Right. So now what I'll do is I'll go over to a shell, and I'll pull the file over here. Now, even for, one thing you'll notice is that for, even for a short run like that, we got, how many is that? It's 8 megabytes of tracing code. So you got to watch out. This can get into some pretty big data. And then let's run the Traceview program. And it comes on this window. So let me move it over to that window. Okay, so this actually shows the whole history of the program. Now, we see these red patches here. So what would that be? You put it and you look up at the top, that's the garbage collection, okay? And you can see this is the thread that we created to do the saving on, and this is the main thread. That's the UI thread, the one I keep talking about, and all it's doing is upgrading the progress bar. So what we can do is we can just zero in on a little bit of this. And so this is where it's updating the progress bar, and this is where it's doing the saving. And you can really get in a lot of detail here, okay? So, and all the colors there match the colors on the routines down here. So let's go and look and see what is our most expensive routine. Well, here's an interesting fact. Our most expensive routine is using 65% of all the time that we used is java.io.printstream. So it's all the time is in the print. So my first thought is, oh, that means that writing to the SD card must be slow, and that's why my program is slow. So let's investigate that. You click on this, and you can see, well, what are its children? And we see that of its about half the time is doing the actual println call, okay? And if we look at that, you click on it, and it moves down, and you can see that, well, it's spending, I got lost. Let's go back to the top. Println. Yeah, it's spending about half its time doing new line, and so this is actually the actual I/O. But here's the interesting one. It's spending 53% of 60%, so 30% of all the time is being spent in string.valueOf. And if you look inside here, you see that it's spending all its time in JSON object.toString. And if you look at that, you see it's spending all its time in JSON object.write2. And if you look at that, you see it's spending, a huge amount of its time in converting a JSON object into a string. And if you keep drilling down here, you see that it's actually spending all its time in string buffer.append. So at least a third of the time in this program isn't being spent reading from the system. It isn't being spent writing to the SD card. It's converting a bloody JSON object to a bloody string. Okay? That's a very nasty surprise. So if I wanted to make my program faster, what would I do? Well, I don't know. I'd think of a bunch of things. Now, in this case, I actually don't care, because this program you only run once on your old phone, once on your new phone. It's fast enough. But so I would find a better way to persist the stuff onto the SD card. I would find a binary encoding, for example, so that I don't have to go through JSON. Or I would go find another JSON library that has better performance. I mean, it's really stupid to convert like 300 phone calls into JSON. It takes several seconds. I mean, that is just very, very bad performance. Okay, so let's go back to the slideshow here. And that is really about all I have to say. The lessons are really, there are only two really important lessons I leave you with. One is you must respect the user, and respecting the user means you must respect the UI thread. Respecting the UI thread means you must never do any significant work on the UI thread. If you want to avoid doing this work, I recommend that you check out the Async Task class and the Intent Service task, which make it much easier to do things in the background without a lot of extra work. If you want to make your program faster, don't guess, measure. Probably your best tool for measuring is Traceview. It's pretty easy to set up. It's pretty easy to use. It's pretty easy to understand the result. You really have no excuse for not using it. In fact, you should assume that anytime you make a program, you should run Traceview on it a few times. My friend Chris Pruitt, who was with me in the keynote, he wrote a very nice little Android game called Replica Island. And he said he lived in Traceview for weeks, just figuring out where the performance was. There's another nice tool that comes with Eclipse called MAT, the memory analyzer. If you're having memory leaks, it's very useful. But really, I think sort of the primary profiling tool is Traceview. Okay, so that's all for now. I think we have some time for questions, but I want to leave you with the message that please respect your user, respect your UI thread, and measure before you change anything. Thank you. Now, we have 4 minutes by my calculation. If somebody would like to ask a question, do we have an interpreter? Well, we have the interpreters there. Yeah, okay, so go ahead. If somebody would like to ask a question, you'll need to find a microphone. Are there, do we have a mic? Right. Oh, can you get me a
遠藤と申します。
just break it.
Android の今後のロードマップについて伺いたいんですけど、ブラックベリーと比べて、 ブラックベリーと比べてセキュリティ、Android の今後のロードマップについて伺いたいんですが、
Okay, yes, please.
Android の今後のロードマップについて伺いたいんですが、
Oh, 4.
Okay?
Interpreter? Can you? Okay, now we're okay. Yeah.
ブラックベリーと比べて、セキュリティの面で Android はまだ発展途上なところがあると言われているですが、例えばファイルシステムの暗号化とか、SQL のデータベースの暗号化っていうようなフィーチャーが Android 3.0 で導入される予定があるかどうかっていうのを伺いたいですが。
I am absolutely not going to make any specific remarks about what will be in Android 3.0 or what the next release of Android will be called. We've never said that it will be called 3.0. I will say, however, that the security group inside the Android team is very strong, and there is nothing in Android that is higher priority than security. So there's a huge amount of very, very, very hard work going on in security.
Thank you. あともう一点よろしいですか。C2DM なんですが、C2DM の、スケーラビリティについて伺いたいんですが、例えば、10万とか100万といった単位の端末に対して一斉にメッセージングしたりということができるかどうかを伺いたい。
Well, we are Google. No, if you want to send to 1 million at the same time, it will not be exactly simultaneous, of course. But I think you will be surprised how fast it is. And also because most of the phones are going to be on 3G networking, there will be unpredictable network delays, right? And also, you know, when the C2DM message goes to the phone, it has to send an intent. The task has to wake up and handle the intent. So there are a lot of variables. And I don't have direct experience with very large-scale C2DM, but right now we have very many millions of Android phones in the world, and this mechanism is being used for Gmail. So Gmail is really a lot of traffic. So I think the scalability will be very good. Anybody else?
デバイスの多様性、ダイバーシティについてお伺いしたいんですが、Android、特に Google TV なども含んださまざまなデバイスが出てきたときに、プログラマーがそれに対してどうやって対処していけばいいのかというのが一つの課題になってくると思うんですが、Google の方ではそれに対してどういったお考えをお持ちでしょうか。
Right, so we call this the compatibility problem. We've been doing a lot of work on this recently. And if you go to the Android developers blog, unfortunately only in English, but it's the Android developers blog, we have had a series of articles over the last 3 months discussing exactly this question. How should an app developer write the app so that it will work on devices that have different size screens, or perhaps will not have a telephone, or perhaps, you know, will not consider Google TV, will not have a telephone, will not have an accelerometer, will not have a camera. And in fact, it is possible to achieve two things. It is possible to write your application so that it will work correctly on a wide variety of devices. And very important, it is also possible to write your application so when it's in Android market, it will not be visible to devices that cannot run it. So it's very easy to say that, for example, that my app uses telephone calls. And then if there is an Android device with no telephone, it will not see your app in the market. And I think we have some positive evidence that this is working well. I had this morning, I have the Samsung Tab. It's a new device, never been seen before. And the screen size is different from every other Android device. It's 1024 by 600. And almost all Android apps just work. They work correctly. I think that if you are an intelligent developer and you read the guidance we give, then it is quite possible to develop an application that will run on a huge variety of different Android devices. And by the way, there is a huge variety of different Android devices coming. Google TV, many different tablets are coming, many different PMPs, devices with no phone. There are many, many devices coming. So I think developers need to pay very careful attention to these practices. Thank you.
Thank you very much.
One more?
今回のお話は主にユーザーとやり取りをする前面に出てくるアクティビティに関するお話でしたけれども、そのアプリケーションの中にはそのサービス中心というか、そのバックグラウンドで常に動いていて、で端末の空いている時はガリガリと、高速に動作して、逆に端末が重たい時、ユーザーが実際にアプリケーションを使っているとか、そういう時はそのアプリケーションに処理を譲るというような、そういったことをそういったことをする方法というのは何かあるんでしょうか。
Right. So if you have code running in a service, there are various calls you can use to to set its priority and to say it's okay to interrupt this, it's okay to kill this, or please never kill this. It's vitally important that this never be killed. And if your service is actually doing something like playing music, you are required to have a little notifier in the notifier bar so the user sees this. So yes, you can have some impact on the priority. But the Android system will always give highest priority to the user interface thread. So, if the user pulls down the notice bar, then that will take priority. And if you have a service, the service will be slowed down, absolutely. Because, the priority is that this is an interactive device. So you can request that your service receive good priority, but the user interface always gets the top priority. I think, what time is it now? I think I see. Oh. We are now over time, so thank you for your time, and thank you for coming out, and write great Android apps, please.